You've connected to Cisco Unplugged.
Hello, and welcome to episode 87 of Cisco Unplugged, your show for all things wireless. I'm Dan Klamert, your host here with Al Dumdei. How are you doing, Al?
Hey Dan, doing well. Doing well. We're going to have an actual really wireless discussion today. Talk about some hardcore RF stuff. So this will
Yeah,
be fun.
deep dive. Get on your propeller caps here. We're going down into the
That's
weeds
right.
here, so it's going to be
Right. We
good.
were talking about Taylor series and that kind of stuff, preparing for this. So yeah, might want to break out your math. No, we're not going to go to that level.
Yeah, so we're talking about the real world interference detection and mitigation lessons learned here from the field. So, with that, we'd like to welcome back Ian Procyk to the show. How are you doing today, Ian?
I'm doing good, guys. How's it going?
Pretty good. Where are you at here
Good.
today? Looks like you got a lot
Uh,
going on there.
I am at the CanSec Defense Conference here in Ottawa, in
Nice.
Canada, and so you might see some people in uniform walking behind me here, but we'll see how she goes. I'm kind of nestled into a little corner, so
So they're not looking for you, just to be clear. They're just hopefully
well.
passing by, and yeah,
One of the concerns is there's lots of countermeasures equipment here, and my stuff may be subject to some severe interference. We'll see.
hopefully, yeah, hopefully not. So before we get
We're
rolling here,
talking
just a
about.
couple. Oh,
Go ahead, Dad. Sorry.
no, I was just going to go into some of the pre-show reminders. Go ahead.
I was just say, you want to talk about spectrum analysis here? You can geek out to the max. There's a lot of signals intelligence equipment on the show floor that's way cool.
I'm
So,
sure.
Except they call
but
it what?
beyond the budget of pretty much all of us normal folk.
You got to
Yeah,
call it ELINT and comment when you're there, right?
Yes.
yeah, it's a much bigger budget than our show budget here, which is $0. So, um, so before we get rolling here, just a couple quick reminders. We are taking questions via Slido as usual. So if you go out, you'll see the Slido reminders there and how to join. If you found us on YouTube and you're watching via YouTube now, the Slido link is below the video that you're watching. You can join there. The passcode's there as well. And submit your questions. We'll get to those live during the show here. And speaking of YouTube, we are recording this and are live now on YouTube. YouTube.com/@get unplugged is the our channel, and you can go out there. Please like, subscribe, and turn on the little bell notifications. You will be notified when we do go live with new great content. So thanks for tuning in this week. We also do want to remind people next week we will have a special episode here from Cisco Live. We are also on the schedule at Cisco Live. We do have a session Tuesday morning. So that's our Titans of Wireless. We've done a show hyping it on the channel here. So if you're curious, you can check that out. But we'd love to see you, love to have you out there. If you're out in Vegas in our session Tuesday morning, it's BRKEWN 1012 is the session. So it's going to be a live format where we take questions with the Titans of Wireless, some
It will be
great
entertaining.
principal, distinguished engineers, and just all around super smart, great people.
Yeah, it'll be entertaining because there's a lot of comedians on that group too. So
Yes, yes, that's their night job. So
that's
yeah.
right. We'll have
No
some
cover
fun.
charge.
No cover
Exactly.
charge.
Yes.
That's right. The best show in town.
Yeah. So thanks. We do publish a schedule too of the upcoming episodes, and that's out on our YouTube channel as well. It's the first link below our title bar on the Unplugged title bar on the channel page. You'll be able to click on that. You'll be taken to our web page that has the upcoming schedule of episodes. So if you're curious about what's on the docket coming up, you can always check that out as well. So let's get to it, though. Let's get unplugged here and start talking about pesky RF interference. I think I called this Wi-Fi interference this episode, but really it's all things RF interference and how they impact Wi-Fi and what you've seen and how we mitigate it here, Ian. So really looking forward to diving in here today.
Yeah.
Yeah, let's have some fun. So
Yeah.
we'll get the screen share up there. I think hopefully that's coming through, and we can kind of piece through this. So I have some crazy pictures of old stuff, and I'm a ham radio geek. Many of you guys know that, and actually Tom, who's the man behind the curtain on the production, is also another ham radio guy. So there's a lot of us in this crew, if you will, and in the company. I'm a collector of a lot of old radio stuff, and I got looking behind one of my old 1937 RCA console radios, and they advertised the Magic Brain. And that was the, the big marketing hype back in the day with the tuning eye vacuum tube so I had to put that in here because kind of thinking about spectrum analysis and the clean air chipset, right? Anyways, really, I just wanted to boil this down to some, let's kind of go back to basics a little bit here and talk about some of the fundamentals, things that may be adjacent to Wi-Fi that can interfere with Wi-Fi. We'll talk a little bit about harmonics, things, that can happen from out-of-band emissions that fall into Wi-Fi when they mix with other things, or have non-linear amplifiers that cause us problems. Why this is an all your senses activity. Over the years, I've had many managers. Actually, I think it's 12 now I'm up to inside of Cisco. And an ongoing theme, with the exception of Dan, 'cause Dan's been in the field, he gets this. Why are you spending so much time in the field, Ian? How come this is so expensive? How come Wi-Fi is, a field activity? And the reality is, you know what? It's the last remaining analog technology. And we've got shades of gray over the air. And you can walk into a space or a venue and you never realized in your debugs in your system that there's actually this adjacent equipment that is totally tangential to what you were thinking about or looking at that's causing problems, right? And so when you're on site, you start to realize these things. So anyways, and then just tools of the trade and tips for direction finding things. And you know what? I'm a ham radio geek. Like I said, QRM is a Morse code, Q code, actually established in 1912, international code for interference. And so this is not a new concept. We've had interference as long as there's been radio, right? So
it's interesting you
go
say
ahead,
that
Al.
about it's interesting you say that about interference. We're getting ready to start Cisco Live. During Cisco Live, we have people walking around. That's all they're doing is trying to hunt down interferers, especially like in the preparation for keynotes and stuff like that. So yeah, that's to your point. Analog is still analog. I mean, there's a lot of digital stuff that's going on, but it's an analog carrier at the end of the day, right? So
absolutely. And it's spectrum that is shared, right? There's, Wi-Fi is probably one of the last things to come to this band. And ISM band has been around for a long time. And a lot of these frequencies have been used since the beginnings of radar and, wireless, right? So any case, I couldn't escape. I'm at a Canadian security conference. I had to have a Canadian picture to talk about spectrum. And so here's some Canada geese at the lake near my house. And I'm actually looking at an HF radio that I'm
some of the meanest animals
Yes.
on the planet.
absolutely coming to hunt you down with your interference.
Like there's some kind of
if we
personal
find
thing
any
going on.
interferers at live, we're just gonna sick the Canadian geese on them. That'll
That's right. That'll
get
fix
them out of
there.
So, one of the things here, and those of us who are in this business, we've probably seen charts like this before. There's a lot going on in the RF spectrum. We're really locked in on, 2.4, 5, 6 gigs now with Wi-Fi, but those bands have been in use long before Wi-Fi for other things like I was mentioning before. And if you kind of look peripherally at what's in and around that band, there's all sorts of stuff. Cellular is right next to 2.4. And, we have had filtering on our radios over the years to try and provide isolation. I worked problems with customers where, on a mast, they put a wireless mesh radio, like a 1572, and then right on the same mast, they put a cellular radio to do wireless backhaul over cellular. And then they were complaining about the fact that the performance on Wi-Fi was crap, and sometimes the performance on LTE was crap. And reality is you got two antennas on a pinwheel that are only 2 feet apart that are like literally transmitting at a watt at each other. And, a little bit of vertical separation would have helped solve that problem. But you just need to be aware of these things, right? And so I had, AI disclosure here. I had AI create this for me. And Al, you can fact check me on this, but we've got this concept in Wi-Fi. Why does this matter, right? Why do I care about non-Wi-Fi signals? And I guess the problem statement here is if it's not Wi-Fi that's on the spectrum or on the frequency, if it's something else and some carrier signal or wave or whatever, what can it do to you? And what it can do to you, quite simply, is if it's above a certain threshold, it can actually block you from making a transmission. It will lock up your transmitter in Wi-Fi because Wi-Fi is polite. It's listen before talk. And so there's some thresholds here that are of interest. There's, a signal detect threshold, which is quite low at a 20 meg channel. It's minus 82 dBm. And then there's an energy detect threshold, 20 dB above that at minus 62. And that threshold is sitting there to say, hey, we're sensing a lot of RF power on this channel. We're just going to hold off. And if you've got a continuous transmitter, something that is always on the frequency, you know what? Your beacons are just halted. You're off the air until that clears up.
Yeah.
So go ahead, Al.
If it recognizes the preamble for Wi-Fi, then it's the minus 82. But if it doesn't recognize the preamble, if it can't decode the preamble, then it's interference and it falls in the minus 62. So that can be other non-Wi-Fi signals. That can also be Wi-Fi signals that's gotten so interfered, if you will, right, that it can't decode the preamble off any of them, right? So there's a lot of different ways that can occur, but you're spot on. The energy detect is, but even if you don't hit energy detect, right, it's impacting your signal to noise ratio, right? That's the other
Absolutely.
So, yeah.
And that's critical to point out, Al, actually, right, is we think about wireless as having this totally clean channel and we're the only thing on it. But, the MCS rate that you've got, your bit error rate is a direct result of your signal to noise ratio. And if your noise floor is elevated in a venue like this, because you've got, countermeasures equipment running in the background and everything else, your performance is going to suck, right? So how do you look at this stuff? How do you find this stuff, right?
Oftentimes radios, they can't instantly adjust to this, right? So if there's interference that starts occurring, if it bounces in and out, right, it may think, okay, well, I'm going to transmit at MCS 7 or 8 or what, right? But then all of a sudden it doesn't get through because it doesn't have the signal to noise ratio. Well, then it's got a rate shift, downshift, try again, maybe downshift, try again. Meanwhile, you're adding to the pollution yourself. Your delays are going up, right? So all of this is due to that interference that you're bringing up, right? And it's not necessarily intuitive, but it's part of that what happens when you start to reduce the signal to noise ratio.
Absolutely. And when I'm looking at problems or complaints from end users or partners, customers, whatever, some of the questions I would have are always around, kind of describe the environment this is happening. Is it cyclic? Is there a pattern to it? Is it is this happening at certain times of the day, right? Because sometimes those things provide us with some insight as to what's actually happening. So another thing to think about, and I kind of touched on this a little bit before in the chart of all the radio spectrum, is that we have harmonic relationships. In other words, what is a harmonic? A harmonic is a unintended or unwanted signal that is basically a multiple of the original transmission. So for example, I'm going to give you an example here that I've worked, which is 800 megahertz trunk radio. So these are portable walkie-talkie radios that you'll find in public safety communications, police, fire, ambulance. Even inside of a hospital, you might have security running this in various, systems. And if those radios, if the amplifiers in those radios are not 100% linear, and that's very hard to do, you'll sometimes get some RF generated at the second or third harmonic, and the third harmonic of that band at 800 times 3 is 2.4, right? And you can actually see where that slots in. And so this particular chunk, 806 to 824, is actually the uplink band for most of these radio systems. The downlink, the TX, high power TX, is up higher, 45 meg split. But what this means is you got somebody walking around with a portable radio that's keying up and talking and calling for something, and they're a mobile interfere. So now you're trying to track something down that's on the move, which is a nightmare, right? So
in general,
there's many examples of this. Go ahead, Al.
Generally, it's the odd harmonics that are worse, right? And that's all based. We were kidding about this earlier, and I'm not going to get into Taylor series, but if you want to know more about that, you can just look up the Taylor series math, right? And it'll explain why that third harmonic, the third, the fifth, are generally the ones that you care about. So if something's at 800 megahertz, you probably don't care about the second harmonic because it'll be fairly low, but the third harmonic will be the primary one to worry about.
Absolutely, and we don't typically get into this in Wi-Fi too much, but there's other concepts of mixing, right? So F1 plus F2, F1 minus F2, right? So you got two frequencies that can come together and generate a new product, a difference and a sum, right? And so that happens a lot of times in ham radio stuff where we're dealing with low frequencies and you got high power transmitters, two of them in close proximity, and you get some, new frequency that comes out of this, right? Or I've had situations where rusty fences and act as diodes and demodulate signals, and you get crazy stuff happening as a result of this. You can actually hear a new frequency that gets created on an AM radio just by being in proximity to these things. It's pretty wild.
I'll give you another example. I worked for a while in it was in land mobile radio. Sorry, not ham radio, but similar, right? And we were developing some digital land mobile radio technology, a startup company, and we had this terrible interference that was coming out. We thought of the transmitter, right? And so, but when we finally got up and figured out what this was, there was a neighboring company that had a GPS receiver. Now, this is just a receiver, not a transmitter. But because we were exciting the front end of that receiver, it was re-radiating, and mixing, and causing issues that were so in our receive bands, right? So, yeah, it's you don't think of that, but it was a receiver, GPS. I was like, why would that be a problem? But it still has nonlinear characteristics and can cause that problem.
Yeah, and this is a challenge, across the board with, it's price versus performance, right? And if I'm an engineer and I'm designing a radio receiver or transmitter, is this consumer electronics, or does this need to be, highly, electromagnetic, compliance? Do you need to, is the enclosure metal? Is it well shielded? Is there an RF circulator on the antenna port that, acts as essentially a one-way diode to that signal that can shunt, certain RF to a load. So anyways, yeah, there's always that challenge, which is it's a cost trade-off when you're building something, right? So to that end, here's an example. I'm going to get Tom to play a clip here in a sec. Sometimes you just need to listen, right? And I always think about interference at the baseband, the human ear. If I can hear it, I can just where's that sound coming from? I can locate it. I can work with it. I can troubleshoot it. If you think back to the days of, dial-up modems, what happened when you picked up another receiver in the house and somebody was on the internet, right? That you induced noise and interference into that modem, that carrier signal, and you blew up the bit error rate. Eventually the modem would just hang up. I can't make sense of this, right? So, you got things like this that happen, right? So let's play that clip, Tom, of the LED RFI, radio frequency interference to AM radio.
So I'm sitting here listening to the radio, and I'm like, oh yeah, I'm going to turn on the light here. So go ahead and turn on the light. Kidding me? Battery operated. So this has a white LED.
Yeah, what's the idea?
Unreal.
So
was that AM
it's a little
radio or
animated.
FM radio?
Yeah, it's AM radio, and that's another good
Okay.
part about this. When you're troubleshooting things, you sometimes AM's best because it's amplitude modulation. There's no complexity to this. So if you've got an impulse noise, if you switch your SDR or your spectrum analyzer, if you have a demodulation capability, you can listen in AM. You'll actually be able to hear some of this stuff at baseband and actually what is going on here. In that example, even though this thing is battery operated, the LED driver, if you will, has basically pulse width modulation. It's a dimmer, right? So you can control the brightness in the LED, and that LED driver is chopping up the waveform to produce that brightness. And when you do that, you create something that's very rich in harmonics. And because this is a $10 LED light, nobody thought about putting any filtering in this. And you know what? I'm sitting here next to my nightstand. I'm like, oh, let's turn on this LED. And I'm listening to some distant AM radio station as I'm a radio geek, right? In the evening. And it totally blew up my my listening experience, as you saw, right? Same thing happens to us in the higher bands, in the microwave bands, right? It's just on those low frequencies in medium wave, everything in their dog. If you have this is why a lot of EVs got rid of AM radio in them, because the interference from the powertrain actually causes the AM radio to be so jacked up. You can't, other than a 50,000 watt station in your same city, you can't hear anything, right?
Mhm.
So, anyways, that's just an example, right, of a totally practical, real thing. And we've all been there, right? Why is it staticky on the TV, move the antenna a little bit, or, in the case of radio stuff like this, maybe I would have changed the pattern of that antenna. I could move it around to try and null that out a little bit, or move the light further away, separate the source from the actual device. But if you can fix it at the source and eliminate it, that's the best.
And
I always
for
like to think,
for the kids at home, AM radio is what the old people used to listen to the news and sports on back in the day. So there you go.
we actually
The
had
more
them in
you
our
know.
cars. Turn them on once in a while. Yeah. We instead of using
Totally.
the app.
Long live broadcasting.
Yes.
Yeah. I always think of this, Ian, sort of as pulses, right? So there are two things when you think of interference from pulses. One is the pulse rep rate, right? So how fast that pulse is hitting, that's kind of going to give you the center frequency of where that interference is going to occur. And then the rise time will determine how wide that band is or how narrow that band is. So if it's a slower rise time, so it looks like a sine wave, then it's very narrow, right? But if it's a very steep, very sharp rise time, then it becomes a very wide pulse. And so when you see that AM interference, that generally means that that pulse, the rep rate and the bandwidth is enough someplace where it's overlapping with the receiver. And sometimes it could even be second or third order effects in the receiver, right? So it might be that is much higher. An example of that is when we used to, I used to design handsets. This was back when we used to do analog cellular. It's okay, so don't judge. But when we first moved to digital cellular, one of the problems we had was we would pulse on and off the power amp because you always want to save batteries. So you turn things off when you don't need them, right? We pulse off and on the power amp for GSM, right? And it would basically create a low frequency
chirping in your
yeah, it was coupled into the in-ear devices and stuff like that. And so it was a big problem for trying to figure out how to eliminate that interference into if you had a headset or something like that. So
absolutely. I never forget, your GSM phone next to your computer speakers, this rapid pulsing pattern, and still happens to this day. And movie sets and television, somebody puts their phone next to a sensitive microphone, and you can hear that crapping, that crackling noise into the system, right? So
what we would do is we'd put things like capacitors on stuff to sort of change that rise time so it wouldn't go boom like that. It would just kind of slowly ramp up, rather than instantly ramp up. So
yeah, absolutely. So, I mean, how do you see this stuff, right? Something that often comes up in a question from people and, that are maybe new to this is, and it's maybe a common misconception is, is my access point going to get interfered with by the power lines or this, machinery on the roof or these types of things? And, I think you'll find that generally speaking, when we're up in the gigahertz band, a lot of that stuff is so low energy at that point. Most of it's concentrated sub 1 gig and UHF and below. Most of the stuff we're dealing with in 2.4 and 5 is either harmonics or something that's 800 meg and above, just around us, or in band, right? It's other ISM devices that are doing their thing, which you'll see some examples of here in a few minutes. So how do you see this, right? If you can't necessarily hear it because it's up in gigahertz, we can't hear that high. At least I can't. So, can you get a software-defined receiver, for example, right? You can actually take a look, for example, at this Aronia Spectran here, the high-performance radio, and you can actually, put a demodulator in that and actually listen to the signal, if you will, if it's narrow enough. Of course, we talk about, our tools of the trade and Wi-Fi all the time, and Ekahau, the Sidekick is an example of a really portable unit that's excellent resolution and fast sweep rate. One of the things when you're dealing with spectrum analysis is you want something that is frequently updating the screen. You want what's called a sweep rate. So from whatever frequency you're starting to look at to what you're ending looking at, the band, if you will, I really don't want that to take more than a second or two to populate. If it's taking seconds or minutes to populate, it's not really good for any kind of real-time direction finding and analysis. It's too slow. So anyways, some of these tools are absolutely amazing. It's really a matter of you get what you pay for. Go ahead, Al.
Sorry. One thing when you're dealing with spectrum analyzer, I've always said, Ian and I were talking about, many years ago, we used to have what's called an HP85 spectrum. It was weighed like probably well over 100 pounds, that sort of thing. It was a lot of work to it was not portable, let's put it that way. But
On a cart.
yeah, yeah, exactly. I had to carry it up the ramp you could break it apart, and I had carried up the ramp of like stairs onto aircraft and stuff like that. And that was a lot of work. But the big thing with the spectrum analyzer, the rule is thou shalt not fake thyself out, right? Because it's really easy to fake yourself out on a spectrum analyzer. So, for example, if you hit a spectrum analyzer with a signal that's pretty strong, remember what Ian was talking about, you were talking about just a second ago with the
Mixing.
The third and the fifth, you'll see those harmonics, right? And they'll come up in the spectrum analyzer, and you'll think, oh, I have signals here and I have signals here, but they're not really signal. They're because you have a carrier over here. That's why these exist. So what you do is you put an attenuation in the front. If you put 3 dB of attenuation, and the third order product is a 3-to-1 relationship. So if it goes down by 1 dB here, this will go down by 3 dB here. If you know that, then you know this is a third order effect and it's happening inside your spectrum analyzer. So again, those are one of those things that they're great tools, but you can chase your tail for a long time if you don't stop and go, wait a minute, could this be something that's occurring as an artifact in the spectrum analyzer? And again, that thou shalt not fake thyself out, right? When it comes to that.
Yeah, absolutely. And especially when you're getting into the high-end tools with external antenna connectors and where some of the smoothing may be not being done for you and filtering, right? When you can look at things in a raw form, you got to be very careful, right? Lots of images will show up on the screen, image frequencies and stuff, and you got to fact check it, right? So one of the tools that I recently used is still fairly current, still for sale. I think it's about $9,000 or $10,000. Tektronix USB 3 spec amp. It goes up to about 6.5 gig, if I remember correctly. I used this because we had a customer that was complaining that they were getting continuous transmitter detection on their access points inside of a screen room. There's no other interference around. So we actually had a problem with calibration on the power amplifier of the radio, and we generated this little spurious sideband, if you will, of one of our radios, and we had to use this tool to actually get enough resolution to get right up close to the radio and actually see what we were seeing, right? So spectrum analyzers are your eyes, right, down these frequencies, and if you get the right one, you can actually do demodulation and you can listen to the interference. So you can actually hear it. And why that might be important is if you're trying to hunt things down. If you're trying to just listen by ear, you can tell the amplitude of something. It's getting louder and louder, right? And now you can direction find it. So how do you do direction finding? Well, back to directional antennas. And this is why I'm a fan of spectrum analyzers and tools that have external antenna connectors on them, right? So the Net Ally, for example, has the NXT 2000, I think it is, has a external antenna port on it, so you can put a pigtail on there and get to an end connector or whatever your flavor of the day is. Any of the professional high-end tools, you again get what you pay for. It will have an antenna connector. Now you can stick a directional antenna on there. And here, when you're dealing with directional antennas, you can go crazy. So here's an example of a very directional antenna, just to kind of front this. The antenna you see on the top of this tower, this is actually from the old Trans-Canada telephone system. In the US, it would have been part of Long Lines, the AT&T system, carried long distance calls and television across the country for 50 years. These antennas are absolutely phenomenal. They're extremely directional. You look at their engineering, they were designed in an analog era, right? When you didn't have the DSP to deal with, issues. So you had to make up for it mechanically. So I'm not talking about the antenna on the mast that's in front of me there. I'm talking about the one I'm standing in front of, that's behind me. It's like 3,500 pounds. That antenna has like 43 dB gain at 6 gigahertz, and it's like less than a degree wide. You can see the pattern of it on the left of the screen. Now, that's not going in the back of your trunk to a customer site to do direction finding, but maybe something like this is, right? It's pretty sweet, though. I'll tell you, if you're plugged into one of those things with a Cisco access point, you can go a long ways. But anyways, I've done it. So if here's an example of what I have.
That's from the FCC, did you?
Yeah. Uni 3 band, unlimited antenna gain in Canada.
Oh, yeah,
Um,
okay, that's right.
JRC, Japan Radio Corporation, they're just one of thousands of vendors that make antennas. One of them I had laying around. It's decent. It's dual polarity. So you have a vertical and horizontal port on the back. It's small enough that you can kind of put it in a check bag, if you will. I got called to a customer site about a year ago, troubleshooting some interference on site, complaints about performance. And one of the things we wanted to rule out, because it was so odd, we just wanted to rule out RF level problems. And so packed it up, took it to site. And this is the kind of site where getting access to certain areas, there's lots of safety, hazardous type of conditions, right? Explosive gases and stuff. So I wanted to be a little bit away. And so I needed the reach of this directional antenna to probe into a spot. And this antenna is about 9 degrees wide. So 9-degree field of view, basically, and I can hook that up. You can see here, I got a good old 3702. I put it in Spectrum Expert mode. Why have I got a 3702? Well, I'm looking for an interferer in the 5 gig band. This particular network is operating in 5 gigs. It's a mesh network. And I've got external antenna ports. Yay, right? All I need is one. So I just antenna mode A dash antenna and fired it up, and I got my my directional, hooked up there. And Spectrum Expert, the old Spectrum Expert software, is still available for download on Cisco.com. So get that while you can. It's Windows XP era software, so sometime in the future this is going to get pulled, or won't actually load anymore in Windows. But it's amazing for what it was, and I still use it, every once in a while.
Yeah.
But keen eye of you there might notice the name of my AP is KH11, and that's a tip of the hat to the very first spy satellite. So sorry, Al.
Nice. I had a
Or Dan.
question. Yeah, I had a question, Ian, and this may be a difficult question to answer, but I guess taking a step back, if I'm a network administrator here and I'm tasked with a help desk ticket, or user comes to me and says this isn't working or whatever, I guess what percentage of these types of interference issues would you say are maybe addressed like through the infrastructure with like the visibility in the system now in the dashboard
Yep.
versus I gotta, I'm assuming a lot of these very complex, hard to find type of interferers are maybe, more of the exception than the rule. And, you're called in when it's obviously we're well beyond like, let's look in Catalyst Center and see where the interferer is and locate it and find to mitigate it. Or we've already moved around it by changing channels to avoid it and mark that channel. I don't know if that question makes sense, but it's just like,
Oh, it totally does.
how
Absolutely.
frequently are, you having to, and I guess then the second follow-up question would be is you had the slide of kind of the toolkit, if you will. If I'm, the average Joe at the network administrator, like how much of that stuff do I need in my toolkit? Is it, is it everything? Is there one that is kind of a switchblade that does a lot? Or do I literally need to spend, the gamut on all of these types of tools?
Well, Dan, the guy who dies with the most tools wins. So I'm
You're
in
well on
the
your way to winning, that's for sure.
Yeah, they are fun. Don't get me wrong. The guy likes
there's this
tools.
thing called gas. In the at least in the AV world, there's this thing called gas. I have gas, and it's gear acquisition syndrome. And
Yes.
same applies here. So anyways, just back to your question.
Some
Yes,
people
I mean,
collect
disproportionately
shoes. We collect Wi-Fi, interference detection tools.
equipment. Yes, totally.
To each their own.
I think you'll find, our tooling, like our reporting and whatnot, and that's how a lot of this actually starts off. Is the customer's looking at a dashboard, they're looking at, Catalyst Center, whatever, and they're getting alarms about a continuous transmitter.
Yes.
Maybe they're looking at their channel plan. I'll give you an example from a stadium that I've been working on in advance of FIFA here, right? Upcoming games. We're looking at the stadium's RF channel plan. I said, dump me out a report through the system of all the channels in use in the bowl. I want to look at all the channels we have and how many APs are on each channel. See if things didn't look lopsided or whatnot.
Sure.
And I'm looking at this and going, well, hey, like why is there nothing on channel 153?
Why are we avoiding?
Like, there's
this
only
channel?
two.
Yeah.
Exact. Why are we avoiding this? Because yes, we can work around it, but now I've just sacrificed hundreds of megabits capacity, right?
Sure.
So, okay, now to answer that question, if you go back in time, we've had for years the ability to look at our dashboards and try to triangulate using spaces or way back in CMX and MSC, location appliance, where an interferer is physically on a map, which is really cool. Which is another reason why, if you're a customer and you don't have your Wi-Fi infrastructure on a map, that is a huge mistake. Like, you're missing out in some of this analysis. Oh, totally. Where is this thing? Like, I have no idea in my building. I'm getting alarms, but I have no context. So understanding that is really important. I think when it comes to mitigating, which is the other tagline in this presentation, this is a boots on the ground exercise. To your Al's point earlier about Cisco Live and what we do at Cisco Live, you got to have somebody walk the field to locate it, shut it down.
Yeah, the AP's located it. We've maybe marked that channel as exempt here temporarily, and but we're not going to physically zap the thing out of the air, out of the space or whatever. We've got to go and find it. Yep, that makes sense.
Yep.
My recommendation for something like that, and I'm going to meddle just a little bit, but is if you're concerned about that, have a policy. Right.
Yeah.
In fact, have a written policy up front that says, this is what I'll accept. This is what I won't accept. So that when you go out and you find whatever it is you're looking for, you know what you're going to do with it. If you don't have a policy, then generally what happens is you go out there and you're like, okay, there's an interferer. Well, what should I do about it? Right.
Exactly.
It's like, have a policy that, that so you know what you're going to do to deal with it. Right.
Yeah. Let the
lawyers, perfect segue, Al.
Lawyers draft that.
Perfect.
I used to work at UBC, good friends with the crew out at UBC. They may be watching this. UBC over the years has had a robust RF policy, wireless network policy on campus, and it talks a lot about interferers, the pros and cons, and why this is important to make sure the network's running reliably, and what is UBC allowed, or UBC Central IT, what can they do to help mitigate this? What could you expect, right? Like up to and including shutting these things down, right? So here's a policy. If you want to Google search this is a public doc. SC14 is the thing. So take a look at that. Great. And UBC's had that for almost 20 years now, and it's come in handy from time to time. You'll get somebody that's a little standoffish about their thing, and it's like, well, hey man, you realize this thing over here you got going on, maybe it's not critical to this research, but it's affecting this over here. And not only are affecting our network, but it may be affecting some other research that's taking place in this frequency band that the radio science lab needs it for or whatever, right? So anyways, and
that's unusual. I'm impressed to see that policy. So gold star for them.
Good.
Yes. Yeah, it was a tough slog getting it through approvals because this is public spectrum. How can you claim rights to it and all of those things? And there's a bit of a gray area there if it's within your own building and your walls, right? But what can you do from an enforcement perspective? Anyways,
have a policy, have it written, even if you have to adjust it over time. Start with something, right? And now at least you can begin to enforce policy, as opposed to just sort of making willy-nilly sort of decisions. So
absolutely. Let's talk a little bit about some of the interference. Now, if some of you watched the Ekahau seminar we did last week, we did a joint presentation with Ekahau. Some of this might be a little bit of repeat there, but I want to just throw a couple of examples in case you're just watching this video on playback. Doppler radar in Uni 3. Remember, these bands are industrial, scientific, and medical, right? So I can do any of those things in these bands unlicensed without a need for consent. And so what do I mean by this? Well, here's an example of an occupancy sensor. You've all seen these, right? And in years gone by, that window on the front of the occupancy sensors typically been passive infrared. And, heat detection is a good marker of somebody in the room. And so you detect heat and you turn the lights on or off, or you turn the famous thing that drives me nuts in hotel rooms is the goddamn air conditioning that turns off in the middle of the night. And, because you're not moving, you're asleep, right?
Exactly.
So I'm one of those guys that gets on YouTube and finds the hack for every thermostat in hotel rooms and travels with a screwdriver to open it up. And anyways, so occupancy sensors. What does
Need a
this look
balloon.
like? Right?
Tie a balloon to it. There you go.
Exactly.
But you gotta have warm air in the balloon.
That's true.
Travel with it. Travel with a hamster and keep the hamster in a cage in front of the thermostat.
That's
It walks
true.
around.
Yeah.
Okay, nocturnal animals. Anyways, so here's an example from Sidekick, right? This is spectrum analysis courtesy of UBC. They provided me this graphic here. You can see this occupancy sensor that is operating in the Uni 3 band, and you can see the total destruction it is providing to all of those channels.
Wow.
As that's not Wi-Fi transmissions there, that's the RF energy from that occupancy sensor, basically jacking up channels 130 to 165.
Wow.
And so what this was showing up for them as centrally, I mean, this is one classroom out of hundreds of buildings on campus. It was showing up as an alarm as a continuous transmitter in Catalyst Center, right? So, and it's continuous. It's been there for weeks. What's going on? Why is this happening, right? So physically go to the site, investigate this thing, try to understand what's going on, right? This is an example of how it showed up as a classified device in Echo's tool, AI Pro. It's showing up as a video camera, which is not quite accurate, but these signatures are based on best effort, right? So video camera, typically an analog video camera, and TSC camera is going to have a continuous carrier, right? So that's maybe why it thought of this, right? These things are typically going to be like 100% duty cycle, right? They're always on. They're a FM CW radar, frequency modulated continuous wave radar. So here's another example. This is the infamous coffee maker provided to me by Rocky from another customer that I work with all the time. And thank you, Rocky, if you're watching this for this video. He sent me some screenshots from his management console. This is again Catalyst Center and the WLC. You can see there, Dan, on the right-hand side, the continuous transmitters being detected. So he's like, hey, man, I got a real problem here. You can see the air quality index is like average air quality is like 7, 14. This is just terrible, these metrics, right? So if anybody knows air quality, if you're getting below 80, you got something going on. If you're down at this level, you got real problems. Yeah. So, what did he do? He went with a Sidekick. And you don't need directional antennas and everything. If you can get in, if the infrastructure is telling you, hey, it's over by this AP, and just walk over there with your Sidekick and check it out. Sure. So here's what he's dealing with, right? So you'll see in this video here, he's got a continuous signal on channel 153, and he's detecting it next to this coffee machine, it's an espresso machine. And what do you do when you're trying to isolate things? Sources of noise and interference, you start unplugging stuff, right? And you're looking for differences. And sure enough, as soon as he unplugged that, that went away. And you can see it cleaned up there, just right there. So this is the kind of thing that, why would you have a radar transmitter on your coffee maker? What's the deal with that? Turns out that this is actually for proximity detection, right? So just like your occupancy sensor in a room, this is used to determine if you're wanting coffee and you're getting close to the machine, it'll warm itself up. So in any event, I'll carry on here to another example. Go ahead.
Say that would not have been my first guess for interference.
No,
like,
not at all.
Unplug the coffee machine. It's like, what?
Yeah. Wow.
So this is another example of some sleuthing. We've got a medical thing happening here. I just need to move a little bit away from where I am. Just 1 second here. Oh, no. So, yeah, that's okay. The stadium here that I was talking about earlier was dealing with some interference issues. Again, reported through the similar means I was just talking about. And what did we break out? It's a big stadium, right? It's a huge facility. And, it's a little hard to figure out what side of the building it's on because you got an open bowl. So I brought that same directional antenna with me. Mm-hmm. And I brought the good old Spectrum Expert. I also brought a little tool you see on the right-hand side, which is kind of what we were talking about earlier, which is called a Tiny SA, Tiny Spectrum Analyzer. And this is you can see it has a little RP SMA connector on it, and I put an adapter to an N on there.
Yeah, how does that thing balance that giant antenna on top there without tipping over?
Very carefully. This is good to just put in your hand and walk around, right? And that's what I was doing with it.
Yep.
So, but you'll see here when you zoom in on this, you see this squiggly line.
Yeah.
What you're looking at here is a carrier, a wave, a signal from a radar in this particular case, we found out afterwards, that is unstable in its frequency domain, right? Because the frequency is on the left to right. So this is wandering. We call these things wandering spurs. They're just like meandering up and down the band, and they're just like that occupancy sensor you saw. It is over time drifting. So what you'll see in Catalyst centers, this AP is saying, or the system is saying that it's, getting interfered with on channel 157, and then 10 minutes later it's on channel 153, and it's what's going on, right? Here we are. Turns out through some analysis and with that directional antenna, sleuthing around, we were able to say it's on the other side of this wall, the wall you see on the right side of your screen. And we couldn't get in there because there was a game on that evening. And just give me 1 second here. The game was happening, and we couldn't get into that box, into that suite. And so we ended up going in the next day. A customer did, and sure enough, guess what they found? Another one of those coffee machines by fluke. So these things are becoming a thing. I've had customers, with multi-million-dollar renovations to executive briefing rooms, and I got a phone call a week later. Hey, your Wi-Fi's crap, right? Well, you just put in brand new equipment. What do you mean it's crap? 6 gigahertz, blah blah blah. Well, no, the executives are having a hard time. Their meetings are jittery, and Teams and WebEx is terrible. And we come to find out that the lighting system in the building was all certified LEED platinum, which meant it had an occupancy sensor in it. And an occupancy sensor was in 5 gigahertz, and it just completely blew up all the Wi-Fi channels in there.
So what's the first, let's take that as an example. What's the first thing, and this kind of goes back to Dan's question, what's the first thing you look at before you even go on site, right? What would you look at initially that kind of says, hey, this is an interference problem? Yeah,
absolutely. I'm going to look at air quality index, right? I'm going to look at my tools that I have available. If I'm in a WLC, I'm going to look at AQI. I'm going to look if I've got the dashboard up and either Meraki or Catalyst Center. I'm going to look at my spectrum analyzer in Intelligent Capture. You can click on spectrum analyzer mode. I can look at this. What I'm looking for is I'm looking for straight vertical lines. I'm looking for stuff like this. You can see this peaky line here, right? I'm looking for things that kind of look a little bit out of the norm, because Wi-Fi is going to be a 20 meg or a 40 meg or maybe an 80 meg wide hump, and it's going to look kind of flat top. It's going to look like this badge kind of sneaking up across the bottom of your screen, right? These narrow spiky lines are non-Wi-Fi things, most typically. And if I start to see this, I'm going to go, okay, I might look at some other APs in the area that surround that and see, okay, well, can I say where specifically it is? If I'm not using triangulation tools and like spaces or whatever, I might just play hot and cold. I'm going to go to this conference room and look at the AP there. I'm going to go down the hall, look at it over here. And this is the one it's being, the worst. I had a customer a number of years back, Al, where we had, again, complaints by the windows. And the complaints were, that performance was terrible on a specific channel. And they determined this through, weeks and weeks of investigation. And it's only near the windows. And when we got on site to look at this, we determined that there was a directional video camera link from the intersection, from the traffic camera on the intersection that was shooting right through the corner of their building on like channel 149. Wow. And, that's a continuous transmitter. It's non-Wi-Fi. It's a microwave point-to-point shot that is just blasting on the channel as it can. And so the solution in there was, okay, let's remove that channel from our RRM channel list, right? So we never put an AP on, because we can't tell the city to move their traffic camera. It's their right to have it there. Yep. Right. Yeah. So any stuff like this, right? You kind of have to sleuth around.
I think one of the other things that's always a good indicator, and this is a lot of times where I start, is channel utilization, because it takes into account Wi-Fi and non-Wi-Fi. Yes. Now, so first thing is you say, I have high channel utilization. Now you say, okay, go to the air quality index, go to the spectrum analyzer, that sort of thing. Because it could be Wi-Fi. That's the problem. It could be just a real busy channel. It could, there's a lot of things but that tells you up front, I got a busy channel. And to your point of like, we were talking about earlier about the energy detect threshold. I mean, if I have a CW signal that's in there, it's hitting that energy detect, it's going to look like the channel utilization's through the roof. It may not maybe just be a little spike in that, from the spectrum analyzer. But you now know I have something to determine on that channel. First thing is it Wi-Fi or is it non-Wi-Fi? And that's where you kind of immediately start going to air quality and spectrum analyzers. And then to your point, now we've determined it's non-Wi-Fi. Now you're on site.
Absolutely.
Most likely.
100%. Yep. Anyways, last few things here before we kind of wrap it up. Another kind of in the geek factory here. This is when we got AFC, before we got AFC in Canada, 6 gigahertz outdoor support. One of the questions was, well, who's out there? Who are the incumbent users? And there's actually some really cool web pages you can go to. We won't have time to demo them here, but in Canada, at least, that you can type in, the frequency ranges and your location, and it'll actually give you pinpoints on a map, all the licensed users in that area. And you can actually, look at them and what their antennas and everything are. So you can understand the licensed users in the spectrum. But what else is out there? So Jeff, myself, we built up this thing, put them on the high rise that basically is a high gain sniffer, and it had a remote controlled. So this antenna could be remotely controlled from anywhere on the internet. And so you could actually aim it at different directions. You can see here, there's the control equipment in the rack inside. And if you watch that video slowly, you'll see that antenna move it around. So you could pan and tilt it and track things with it and whatnot. And we use that to look at, interference and whatnot, as well as link testing. We just did a number of things over the years for just long range point to point link distance testing. But stuff like this is kind of cool. Here's an example. Cool. Here's an example of a bad actor, right? So this is an example here. I'm going to just play this clip. There's no audio in this clip. I'll just talk over it. This is the resolution is not the hottest here, but this is again a 2513 patch antenna. Back to my external antennas. I'm always on these external antennas because it helps me understand where things are coming from. I'm only got one port hooked up here. I've got it hooked up to a this is actually an old Air PCAP NX that had MMCX connectors on the side of it and to a type N, right, pigtail. And I'm down here at a customer site because users near these windows are complaining about their connections dropping. What the hell is going on here, right? So get on site, fire this up, and what we're noticing is there's a lot of messages. This is from WCS. That's how old this example was. Wireless control system was saying, your network is being contained. AP is being contained by such and such, right? And just random containment messages. Okay, well, who's containing us, right? So break out the antennas, directional antennas. I ran a Wireshark packet capture because the Air PCAP NX you can dump out. It's a Wireshark enabled. You can see it right there, just kind of at the end of the thing. And I'm right next to the port, right? I'm down at the waterfront here. And here's my Wireshark running. And you can't see this, a little blurry, but I've got a specific filter here for broadcast deauthentication frames. So any broadcast deauthentication frame is going to show up as red, and it's the only thing I'm seeing. And so now I can turn this antenna around and use its directivity to actually look for these isolated, these transmissions. And sure enough, we determined that it was, through some further investigation, that it was ships in the port that were coming in from other countries that had AP containment turned on, which is illegal. And that is basically a logical attack on your network, right? Excessive probes. We talked about this in the Akahau thing. This is again a UBC example. They were dealing with, getting probe flood alarms in their system and packet capture showing tons of probes, right? And they grabbed some of this from, remote sniffer AP. And what is causing all these probes at 1 megabit per second and 2.4? And they used directional antenna on a AirCheck G2, right? You can see the actual little paddle antenna there. It's like a little log periodic antenna to hunt it down, right? And got into the laundry in the basement of one of the student residence buildings. And all the coin-operated laundry has a 802.11b radio on board. And that radio is used for whatever it could be used for, management of the washing machine, reporting of its supplies or whatever. But if it's unconfigured, it just sits there and blasts probes into the air.
Wow.
And basically you've got banks and banks of these things just doing that all the time, right? So this started a conversation between the university and the manufacturer about, well, what's the deal here? Can we disable this? So how do you mitigate this rather than yank the plug to the washing machine? That wouldn't go over too well with the students.
No.
So anyways, this is not a a RF energy problem as much as it is a logical attack problem, and locating a logical, not an attack, but a logical misuse and abuse of spectrum, right?
Yeah.
Abuse of the
I
channel.
mean, it's a DOS. It's not an attack, but the result
The
is
denial of service.
a DOS
Yeah.
effect.
Absolutely.
Right? Denial of service. Yeah.
You got one, when you're making these washing machines, you got one of them in the lab on the bench, and okay, you got some beacons, you got some probes, but now I got like 30 of them side by side, in a big building. Okay, the last one I wanted to share with you today is it's kind of an interesting one, and it's, again, because maybe I'm a tip of the spear for a lot of things like this when it comes to escalations and whatnot, at least up here in Canada, but and not belittling work from any others or TAC or anything else. Just sometimes if you work in Wi-Fi, you're kind of adjacent to these things. So I got an email from a partner, great guy, worked with him for years, and he said, "Hey, and I'm investigating this situation with a customer just upgraded to a brand new Meraki deployment." This is a couple of years back, and this is a motorcycle dealership, and so what they're reporting is the day after they upgraded their Wi-Fi, they can't start their motorcycles in the dealership. and it's like, well, these things can't be related, can they? And the customer, I mean, they're motorcycle mechanics. They're not RF engineers, right?
Sure.
I wouldn't expect them to know about this. So they're like, prove it to us. What's the deal here, right? Okay, I love a challenge. So Tom, I'll get you to roll the clip about this, and we should hear it in a sec.
Everyone, a quick update on this whole Meraki CW9164 motorcycle interference at the Harley Davidson dealership. Well, this just happened to be totally coincidental. The Meraki installation went in the same day this problem showed up, and my experience with this type of system or these types of problems is, generally speaking, nothing to do with Wi-Fi, generally RFI, radio frequency interference in the UHF band. These keyless entry systems typically universally operate in 315 or 434 megahertz. So that's exactly what he calls out in the email. This is Alex from the partner reaching out for some assistance on this. So did a little bit of driving last night just to see what was going on in the area. So Trev Dealey Motorcycles, pretty big dealership here. You can see kind of inside the store, probably about 50,000 square feet of space. Nice setup. They're located right on the highway, and so it made it easy for just doing some drive testing. So as you can see, they're right here, and they face the highway. So went down the highway and just put the receiver in my vehicle up on 434 megs to see if I could actually hear anything. So let's just pull that up here and show you an example of what that sounds like. Here's the receiver, 434 megs, and I'm about a block away right now, maybe a block and a half away down the highway. 434 megs eastbound Highway 1 at Boundary Road. There's Maple Leaf Storage here. You'll hear the carrier come up in a second. There it is there. Getting louder.
That warbling noise you're hearing.
Still there. We're at Boundary Road. There's the Mercedes dealership. Okay, just about gone now. Okay, so to put that into perspective, here's Maple Leaf Storage that I called out as I was driving southbound here. And here's the Mercedes-Benz dealership down here. So this is a distance of, let's just see here. $2,500 feet. So, went into the parking lot of the dealership last night with a little test tool that I have, a little SDR, software-defined receiver. What I'm using for that here is just the RTL SDR. These have been around for a long time. These are just really inexpensive, probably like $40 now. At that and a little telescopic whip antenna that I could optimize for UHF. So, these SDRs, great, just plug them into your laptop, and using a program called SDR Sharp, was able to just walk around the perimeter of the building and determine where the signal was peaking at the most. And certainly that's what it looked like there. When we zoom in on the spectrum, you can actually see the interference. So 433.9 megs is dead on where we're dealing with here. So okay, went back this morning, and this is the service entrance here, the service bay. So I just drag the stick man in here. You see, this is the area where they bring bikes in for service. And so went into the service area and just a game of hide and seek, hot and cold with the laptop. Was able to actually pinpoint this pretty quickly.
Okay, so it is August 3rd. As soon as that fuse is connected, the signal comes up.
You can see how wideband this is now that we're right on top of it here, and I've gained down the receiver substantially. You can see gain is actually 0 dB here versus where it was when I was outside. Gain outside was 16 dB, so I gained the receiver way down in order to try and get right on top of this thing, and sure enough, it was right under the bike seat.
Okay, let's just connect that fuse. Signal's gone.
So because of this situation, basically what was happening was this is a continuous transmitter, right? It's 100% duty cycle. It's on the channel the whole time, which basically prevented any of the bikes in the area, any of the key fobs from actually doing the proximity unlock and proximity start on the vehicle. So they had to roll everything outside of the shop, except for this one bike that was laid up for other service work. So there we are.
So that bike was doing a denial of service attack on its fellow bikes.
And the bike came in the same night they did the Wi-Fi upgrade, right? And
Interesting.
who would have thought,
Yeah,
right? This actually, the
coincidence.
best part is that this was a police motorcycle. So if the
Oh.
police department was causing this denial, so they were doing work on the police's Harley. And what happened
Wow.
here was the unlocking system, it's an UHF, the 400 megahertz unlocking system, just went sideways. It was like 10 years old.
Yeah,
It started
glitch.
going into oscillation, right?
Yeah.
Glitched out, oscillation, and just continuously transmitting on that frequency. And
Wow.
you saw from the video, over a block, 2 blocks away, I'm picking this up. And so in
Yeah.
that entire radius, people are having like problems. If you listen to that video again on playback, you hear this chirping noise, like tapping noise in the video. That's everybody unlocking their cars, trying to unlock their cars in that area, right? And having problems. And so these poor guys, for like a couple of weeks after this upgrade, they're thinking the Wi-Fi is causing them this issue because that's
Yeah.
the only thing that changed, right? Well, no,
Wow.
it was this other bike that rolled in. And here we are. But
Unreal.
again, totally tangential to Wi-Fi. The blame comes on the network, right? On the Wi-Fi because it
Yeah.
was what was modified.
Wow.
Guilty until proven otherwise, right? So
Exactly.
this is why understanding the fundamentals to my screenshot here is so important, right? And why I think having a broad understanding of the RF spectrum and the occupants in it and whatnot is very, very useful,
Yeah.
especially if you're involved in mission critical networks.
It's
Well,
it's
I think
also
we're gonna wrap here.
yeah.
Sorry,
It's
go
real
ahead,
quick. It's
Al.
also why I think it's so important to have boots on the ground at times. You never would have found that problem had you not gone out there. So
Yes, exactly.
Yeah.
Yeah.
yeah, we better wrap.
Yep. Thank you very much, Ian. This has been a great episode here talking about
It was a lot of fun.
interference detection and mitigation. Thank you, everyone, for tuning in. And as a reminder, you can find us youtube.com/@getunplugged. Please subscribe, turn on the notification bell. If you want to get a hold of us, you can send us an email, getunplugged@cisco.com, Twitter, X at unplugged80211, or Threads, unplugged connectivity. The Cisco account team can always get a hold of us too. Come on out and see us at live. We do have some swag, some merch here for you. So we'd love to see you, chat with you in Vegas next week. But until next time, stay connected and unplugged. Thanks for watching.